Sir Fred Hoyle was one of the unfortunate scientists who did not receive the highest award in science, the Nobel Prize.
My name is Fred Hoyle. I am the inventor of the well-known words Big Bang to refer to the origin of the universe, but I'm afraid I don't really believe in the Big Bang.
Fred Hoyle gave the name to a theory that he hated. He built some of the most elegant alternatives to the Big Bang, wrote some of the most best-selling books of all times, and became one of the greatest and earliest science communicators in the 20th century.
He was a man absolutely dedicated to trying to understand the universe.
I think he's an absolutely remarkable man. It's probably fair to say that he changed the way we see the world.
His contribution to nucleosynthesis formed one of the very important bases of overall structure of modern astronomy, as it were.
He did not necessarily believe something which was believed by everybody.
Being my father's daughter was a bit like being the daughter of a pop star. You have no idea the excitement my father could generate.
I don't believe in the Big Bang. It seems to me that it is not likely to be correct. The idea is not really to find anything new, but to confirm what you think you already know.
Long before Carl Sagan was a sparkle in their cosmos' eye, then something extraordinary happened. Hoyle proved himself wrong, not right. His own calculations, his own research into how stars form the elements, that his hated rival theory might actually be correct. The helium abundance he discovers cannot be explained by how stellar nucleosynthesis alone would have predicted. It pointed back straight to the origin of the primordial fireball he spent his whole career ridiculing. That's right. He proved that these objects, these meteorites that you get when you go to my website, briankeating.com, if you're lucky enough to win one, that they were produced in the bellies of stars that went supernova. But the other elements, the lighter elements, the first few elements on the periodic table's upper left-hand side and upper right-hand side couldn't be produced in the stellar cauldrons that he and his colleagues had revealed the inner workings thereof. In other words, the story gets more fascinating the deeper he gets into it, and it gets more infuriating as well. Because the truth, as it turns out, is that everyone was partially right and partially wrong. The critics of the Big Bang, the complimenters of the Big Bang, those that thought they understood how the light elements were formed, they all were right and wrong at the same time. And some of them would go on to win Nobel recognition. Now, any lesser scientist would have retreated after being proven wrong, but Fred Hoyle does something that defies the scientific norms. He published the evidence that undermined his own life's work. He followed the data wherever it would lead and then spent most of his career exploring ideas so radical they make his favored, precious, steady-state cosmology look conservative. He promulgates the idea of panspermia, the idea that life comes from space. He makes wild speculations about pterodactyls, those dinosaur avians that ruled the early Earth's airspace. He's an avowed atheist, proposing that the universe shows telltale signs of intelligent design. He was a complicated man, a man who gave us the poetic truth that we are all literally stardust, proving once and for all that every atom in your body was forged in the nuclear hearts of dying stars.
Hey everybody, I'm usually the one that asks my guests to judge their books by their covers, but today I'm asking myself to judge my own book by its cover. My newest book, Focus Like a Nobel Prize Winner, is chock full of advice, life tips, and focus and productivity tips from 9 of the world's greatest minds, Nobel laureates ranging from economics to peace to physics, of course. It launches September 9th, which is also my birthday. I hope you'll check it out. And my publisher's gotten Amazon to run a special just for listeners of the Into the Impossible podcast. You can get the Kindle edition for only 99 cents. That's less than a new pocket protector. So go to Amazon and get the Kindle copy today, because this special only lasts for the first week after launch.
To me, Fred Hoyle is one of the best teachers I never had. Just a few weeks ago, I found myself watching some old videos of Fred Hoyle and thinking back to those early days in my career when I had access to people who were first-hand colleagues with Fred Hoyle. People like Jeff and Margaret Burbidge, right here at UC San Diego. Mavericks who would question assumptions, follow implications to their logical conclusions, and refuse to accept the comfortable dogmas and orthodoxies just because they were orthodox and dogmatic. And what did Hoyle get for revolutionizing our understanding of stellar nucleosynthesis, for solving one of the mysteries of cosmic chemistry, for the intellectual courage that bordered on sheer bravado and recklessness? His collaborator wins the Nobel Prize, while Hoyle himself is completely ignored, at least twice. This is the story of a contrarian who lit the stars. He scattered the cosmic dust through his equations and never stopped questioning everything, even when it cost him everything, the recognition he richly deserved. Because sometimes being spectacularly right in public while maintaining absolute scientific rigor and integrity in private teaches us more than being conventionally right when the stakes are so low. If you will, Fred Hoyle's Big Bang. He was born on June 24th, 1915 in Gilstead near Bingley on the West Riding of Yorkshire. His father was Benjamin Hoyle, one of the few machine gunners to survive World War I, a fact that would profoundly shape young Fred's understanding of probability, chance, and the fundamental randomness of human existence. In The Small World of Fred Hoyle, he writes with characteristic directness about how his mother, a gifted musician, nurtured Fred's talents without forcing a predetermined path to emerge. Here's our first foundational insight from Fred Hoyle's approach. Cultivate your natural curiosity without constraining it to conventional channels. And this is because his childhood roaming those moors in Yorkshire, developing what he called a crab-like approach to learning, moving sideways, exploring unexpected territories, never advancing in straight lines. Just like those clever crustaceans, the young Hoyle showed early signs of intellectual fearlessness that would define his career forever. At Bingley Grammar School, he wasn't just solving mathematical problems, he was questioning their underlying assumptions. This is the mindset that produces scientific revelations and revolutions. The willingness to ask not just how, but why does everyone assume that something is true? When Hoyle arrived at Cambridge in 1933, he encountered the intellectual giants who would shape modern physics forever. Arthur Eddington, who many believe proved Einstein's assertion of the gravitational effects of massive bodies using the positions of starlight in the 1919 solar eclipse. He'd also meet Paul Dirac, Ralph Fowler, who would later become a collaborator. But instead of being intimidated by these giants, Hoyle approached the towering figures he met as intellectual equals in curiosity. In his first memoir, he describes how Eddington's lectures opened his mind to the profound connection between mathematics and physical reality, an insight that would prove crucial to his later work on stellar nucleosynthesis. What emerges from Hoyle's Cambridge years is a pattern we see repeatedly in innovative thinkers: the ability to synthesize knowledge from multiple domains while maintaining independence of thought. He wasn't just learning established physics. He was already identifying the gaps, the inconsistencies, the places where conventional wisdom felt unsatisfying. And we're going to see that later when it comes to his questioning of the Big Bang narrative. But Hoyle wasn't just a airy-fairy, erudite theorist. He was actually interested in the practical physics. And these would lead to plant seeds of cosmic understanding. World War II interrupted Hoyle's academic trajectory, but in the most productive way imaginable. Now, we all know about the Manhattan Project, and that was the subject of the movie Oppenheimer, but I'm hoping someday to make a movie about radar, which will focus on the British authority, the British Admiralty, because they played probably an equal share of credit is due to the British helping to invent radar, along with helpers in the United States as well, at Lincoln Labs and MIT area. But in his autobiography, Home is Where the Wind Blows, radar was one of the few aspects of his early career education that provided him with hands-on experience in cutting-edge electromagnetic theory and solving problems under extreme pressure. This was necessary to get an early jump on the aerial bombardment, the German planes, Nazi attacks, V2 rockets, and so forth. They were using radar, and they had to develop it and invent it. We take it for granted now. It's so ubiquitous. But back then, it was new, and the British were really the pioneers in inventing it. Again, along with a lot of help from people like my late, great mentor, Bob Dickey at Princeton, who barely got lost out on his own Nobel Prize. It was kind of the experimental analog of Fred Hoyle. He was an experimentalist who dabbled in theory, and Hoyle was a theorist who dabbled in experiment. Now, here's a crucial lesson for any of you aspiring scientists or innovators. Real-world application deepens your theoretical understanding in ways that pure academic study alone can't achieve. Hoyle's radar work taught him to think about electromagnetic radiation in practical terms, knowledge that would prove essential when he later tackled the processes of stellar atmospheres and stellar energy generation. But it was during the World War II years that Hoyle began his collaboration with a man named Raymond Lyttleton, and they explored the theoretical problems of gravitational accretion. This was far away from his work on radar, but it was something that fed his curious soul. The partnership introduced him to the fundamental question that would dominate the rest of his life. How do cosmic structures form? How do they evolve? How do they generate evidence? How do they conceal themselves? How do they live? How do they die? The intellectual cross-training between practical wartime physics and theoretical astrophysics exemplifies what I call the Hoyle approach to learning. Never segregate practical knowledge from theoretical understanding. The equations that guided radar waves through the atmosphere weren't fundamentally different from the equations describing how starlight emerges from stellar cores, and that starlight traced the properties of those stellar cores, helping understand how they could make these hard, solid iron meteorites from just pure gaseous helium and hydrogen. But we haven't yet hit the breakthrough that would change his career forever. And that's something I call the steady state revolution. And we'll get back to that in just a moment after these words from our sponsors. He gave it a deliberately mocking name, standing before a BBC radio microphone as one of the first, you might say, science communicators, influencers, primordial Carl Sagans and Neil deGrasse Tysons. Hoyle contemptuously mocked and rechristened Lemaitre's theory the Big Bang Theory, which according to some of my British friends is slang for orgasm. Spoiler alert, it's not PG-13, I suppose. We'll talk about panspermia later. They don't have anything to do with each other, though. Don't worry. The name was an insult, a way to ridicule what he saw as a scientifically bankrupt idea. But Hoyle didn't just mock, he built. While the Big Bang Theory would go on to great success in television, and side note, I'm going to be appearing with Mayim Bialik of Big Bang Theory television series fame on her podcast in the distant future. I'll keep you apprised of that as it comes together. Working with his Cambridge colleagues Herman Bondi and Tommy Gold, Hoyle constructed something far more elegant, at least according to him, the steady state theory. In 1948, Gold and Bondi published a qualitative framework, while Hoyle simultaneously delivered the mathematical backbone that made the steady state scientifically rigorous. Here's what separated Hoyle from ordinary critics. He didn't just tear down what he disagreed with. He offered a better alternative. That's the mark of constructive contrarianism versus mere intellectual vandalism and, if you like, hating and trolling in the early days of the Big Bang Theory. The steady state theory solved what Hoyle saw as the Big Bang's 4 fatal flaws, while proposing something philosophically magnificent. A universe with no beginning and no end. Instead of creating an entire universe, all you had to do is create a tiny bit, a speck of matter, continuously created throughout space. Perhaps as much as this meteorite here, the amount of matter in this meteorite here perhaps created only in an entire century in a volume the size of Manhattan Island. But at such a minuscule rate, as Hoyle poetically described it, you'd only need to have an atom per century in a volume equal to the Empire State Building to be created. This reveals a crucial principle about revolutionary contrarian thinkers. The most powerful alternatives often emerge not from incremental improvements, but from fundamentally different assumptions about reality itself. While others debated the details of cosmic creation, Hoyle questioned whether creation was even necessary. The steady state model wasn't just elegant mathematics, it was a profound philosophical statement. Hoyle found the Big Bang Theory repugnant because it seemed to require what he called a state of the universe for which we have no evidence, a moment before which there were no yesterdays, as I call it in my first book, Losing the Nobel Prize. It would be a singular moment of creation that violated the principles of scientific causation. Think about it, a universe coming from nothing, ab initio, from vacuum itself. It's lunacy. At least it was viewed that way almost 80 years ago, 90 years ago. So Hoyle said, just as there are many stars and there are many planets and there are many galaxies and there are many clusters of galaxies, that meant that there was nothing special about our place in the Milky Way or even in the solar system or even in the supercluster that we're a part of. So why not extend our lack of specialization or specialty not only to space? Why confine it only to space, he thought. He said, let's not confine it only to space. Let's extend that perfection, the so-called cosmological principle, let's extend that to time as well. There's no special point in time either in his model. The universe just slowly evolves for all infinity. Well, what makes this period of time in Hoyle's life so instructive is how he used the BBC radio platform not just to popularize science, but to advance it, to build momentum, to build a public backing behind it. And we scientists forget this nowadays. We think we just serve to advance our own curiosity. No, we serve at the pleasure of the taxpayer. You out there should demand that we not only do the science that you pay our salaries to do, but that we communicate it to you in ways that you can understand it. After all, if you owned a Dairy Queen and I was your employee and you asked me what I was doing with the salary that you give me, and I said, oh, you can't understand what I'm doing. It's so complicated. It's so abstruse. I wouldn't have a job very much longer beyond perhaps the end of that sentence. So hold our scientists to higher standards, and that's what Hoyle would have advocated too. He took these lectures on the BBC and published them as a collection called The Nature of the Universe. And it made more forceful the translations of his technical work into layperson language that anyone could understand. It was a laboratory that he could use for testing ideas against the scrutiny of intelligent non-specialists. The lesson for you goes deep beyond cosmology. When you're proposing something revolutionary, maybe to your boss at your law firm or maybe at the car dealership you work at, use every available platform, idea to stress test your thinking. Use artificial intelligence, use friends, use trusted colleagues and mentors. Hoyle understood that explaining complex concepts to general audiences often revealed logical gaps that peer review would miss. And I find that too in these podcasts and YouTube explainer videos that I put out on my channels. It's incredibly valuable to me, and I am encouraging any of you who have an interest to do it for yourself. Try to make 100 episodes, as my friend and blurber of my upcoming book, Focus Like a Nobel Prize winner, Ali Abdaal says. Just make 100 crappy videos, and by the end of it, you'll be awesome. You gotta start somewhere. Now, here comes what I call the stellar forge and the carbon miracle, Hoyle's miracle. Ironic for an atheist. While Hoyle was busy dismantling the Big Bang Theory, he was simultaneously solving one of the deepest mysteries in science. Where do the chemical elements come from? The alpha-gamma of Hermann theory of Big Bang nucleosynthesis was, in Hoyle's view, catastrophically inadequate. It could only explain how the three lightest elements, hydrogen, helium, and lithium, got their start. Everything else on the periodic table remained a mystery. But here's where Hoyle's genius blazed truly brightly. He didn't just point out what was wrong with gamma and the others. He built something better. If the Big Bang couldn't forge carbon, oxygen, iron, nitrogen, all the elements essential for planets, meteorites, and life, they had to be made somewhere else. It was sort of an anthropic reasoning that led him to believe that this somewhere else was the bellies of stars. In 1954, Hoyle made what might be the most audacious prediction in the history of physics. He was studying how carbon could form inside of stellar cores, and the mathematics was telling him that it was impossible. 3 helium nuclei needed to collide simultaneously to create carbon, a process so improbable it should never happen. But Hoyle made the leap of reasoning that bordered on the mystical. Since we exist and we're made of carbon, carbon formation must be possible. It was anthropic logic. Therefore, there had to be some unknown property of carbon nucleus that made its creation efficient in stellar furnaces. Hoyle predicted the existence of what's now called the Hoyle state, a previously unknown energy level in the carbon nucleus that acts as a cosmic catalyst. Without this resonance, carbon couldn't form efficiently, and complex chemistry would be impossible. And not to mention the fact that we wouldn't exist either to ask these very questions. This exemplifies perhaps the most profound principle in Hoyle's thinking. Use the fact of your own existence as a constraint on physical theories. Most physicists were uncomfortable with his anthropic reasoning, but Hoyle pursued it fearlessly, and he was vindicated. The Hoyle state was later discovered experimentally by his collaborator, Willie Fowler, exactly as Hoyle predicted. But Hoyle wasn't finished. In 1957, working with Fowler and Jeff and Margaret Burbage here from UCSD, he published the world-famous B²FH or B²FH or BBFH paper entitled Synthesis of the Elements in Stars, Part 1. I don't think they ever published the Part 2, but the 80-page-long Part 1 is a classic. It explained how essentially every element in the periodic table, the iron, nickel, cobalt in this meteorite, the carbon inside of your body, could be formed in stars, not in the Big Bang. This work represents one of the greatest unifications in scientific history. It connected nuclear physics, stellar evolution, explosive stellar death, and cosmic chemical evolution into a single coherent framework. Hoyle and his collaborators had solved the puzzle of cosmic chemistry by recognizing that the stars are the universe's alchemical laboratories. Now here's an actionable insight. When faced with an apparently impossible problem, look for a hidden assumption that makes them seem impossible. It could be wrong. In this case, Hoyle's anthropic reasoning, the idea that our existence provides clues about physical law, opened up entirely new ways of thinking about the cosmos. As Hoyle's career progressed, his willingness to challenge orthodox theory led him into increasingly controversial and uncomfortable territory. His collaboration with B²FH produced a series of books, Life Cloud, The Origin of Life in the Universe, Diseases from Space, Evolution from Space, and Cosmic Life Force, that proposed panspermia, the idea that life might have originated somewhere else and then been brought here by meteorites, as our origin story for how life on Earth could have formed. Still an outstanding problem to be solved. This period in his life reveals both the strength and the potential weakness of Hoyle's intellectual approach. Absolute independence can lead to profound insights or sometimes rabbit holes from which spectacular errors emerge. Sometimes both can happen at the same time. His panspermia work was largely rejected by mainstream scientific community, but it raised important questions about the probability of life's spontaneous emergence. And just a reminder, go to briankeating.com/edu if you, like me, have a .edu email address and live in the United States, and I'll send you one of these beauties, which will have some life on it because we package them and ship them out to you, and we probably get some of our molecules on it. Then, in 1977, Hoyle's book on Stonehenge supported the hypothesis that the ancient monument was an astronomical calendar. Now, I was just at Stonehenge. Now, while some of his specific claims were later disputed, his interdisciplinary approach, applying modern mathematical analysis to archaeological questions, exemplified the kind of brilliant cross-domain thinking that produces unexpected genius insight. Now, the lesson here isn't just about the correctness of any of his particular theories, but about the value of intellectual courage. Science needs people who are willing to explore ideas that seem absurd to their contemporaries. Most such ideas will indeed prove to be wrong, but the few that prove to be correct can revolutionize our understanding of the reality of the universe. Now, he was a great storyteller as well. He was really the role model in many ways, I believe, for people like Carl Sagan, because he wrote science fiction novels that deserve serious attention, not as entertainment, but as extensions of his scientific thinking. His first novel is perhaps his best. It's called The Black Cloud. It imagined life as an intelligent interstellar gas cloud, a concept that emerged directly from his astrophysical research. This wasn't fantasy, truly. It was a rigorous extrapolation from known physics. What Hoyle understood, and what every innovative thinker needs to recognize, is that science fiction isn't always escapism from reality. It's a tool for exploring and playing with ideas to take the logical consequences of current knowledge to their inevitable conclusions. His novel Ossian's Ride, October 1st is Too Late, and The Fifth Planet, co-written with his son Jeffrey, explored the themes of time, consciousness, and intelligence that we still explore today. And these are questions that were central to his scientific worldview. His collaboration with John Elliott on the television series A is for Andromeda, later turned into a novel, demonstrated his understanding that science communication requires multiple formats, multiple modalities, and different approaches. The series recorded millions of viewers worldwide with sophisticated ideas about AI and extraterrestrial communication. Concepts that seemed like pure fantasy in 1961, but proved remarkably prescient. The deeper principle here, use imagination as a scientific instrument. Hoyle's fiction wasn't separate from his scientific labors. It was a laboratory for testing ideas about intelligence, consciousness, artificiality, and the nature of human existence and life itself. Hoyle's popular science books, Frontiers of Astronomy, Of Men and Galaxies, Galaxies and Nuclei, and Quasars, Man in the Universe, Astronomy and Cosmology, they weren't just translations of technical knowledge for lay audiences. They were integral to his scientific process. Books like these and the works of Isaac Asimov were so inspirational to me. Again, this series on the science is kind of a fantasy for me to explore fan fiction, ways, or fan nonfiction, really, for me to explore and interact with my heroes that have long since departed. And stay tuned for future episodes I'll be featuring, including encounters with James Clerk Maxwell from my trip to Scotland this summer, my encounter with Lord Thomson or Kelvin from Glasgow, as well as my encounters with scientists both living and dead. Of course, my hero, Michael Faraday, my later hero, of course, my Italian hero, Galileo, but Faraday is certainly my British hero. Stay tuned for upcoming episodes of The Scientist of all three of those titanic figures. Hoyle understood the basic principle that every scientist should be a communicator. If you can't explain your ideas to clearly intelligent non-specialists, you probably don't understand them yourself. His popular writings forced him to confront the logical gap, unstated assumptions in his technical work. Professor McCree's review of Frontiers in Astronomy in The Spectator compared its significance to Darwin's Origin of Species. Now, Darwin will be covered in an upcoming episode of The Scientist as well, but this wasn't hyperbole. It was a recognition that great popular science writing can be as intellectually revolutionizing, as thrilling, and as important as technical papers are. Hoyle's books shaped the worldview of an entire generation of scientists and science-minded citizens. The actionable insight to you? Treat science communication not as a side hustle or something that not serious scientists do or real scientists don't do it. I've heard it all. Quite confident and comfortable in my scientific bona fides. Don't treat it as a side hustle, but as an essential component of your scientific worldview. The discipline required to make complex ideas accessible often reveals their true structure and their true importance, and it helps you memorize them and internalize them. Now we come to some of Hoyle's less successful contrarian insights. And this could be titled When the Universe Fights Back. In 1965, the CMB, very object, the cosmic microwave background that butters the bread around the Keating household, as I always say, was discovered by Arno Penzias and Robert Wilson. Wilson's still alive. Penzias died a few years ago, but I got to meet him 20 years ago at Berkeley when he gave me, along with Charlie Towns, a Young Scientist Award for Best Scientist under age 40 on the occasion of Charlie Towns' 90th birthday. And Charlie lived to be about 100, I believe. So it was quite thrilling to receive that award from the discoverer, the archaeologist of cosmic history that revealed the CMB, which you can see in the back, and a beach ball behind. This was the death knell for the steady state theory. Many people, including past featured guests, so to speak, Steven Weinberg, said that the steady state theory was preferable to the Big Bang theory for many reasons, but not the least of which because it least resembled Genesis 1:1. It had the least supernatural God shenanigans, as he called it, involved in it, and it had a thermal origin. It avoided the thermal origin of the Big Bang because it didn't have an origin. But Hoyle was not the same as most cosmologists. He didn't take on the CMB with the same lack of concern that a true skeptic would have. He was the only cosmologist bold enough to challenge the CMB's interpretation as the fossil heat from the Big Bang. And his motivation wasn't to surrender. It was to continue what he saw as his mission to demolish what he considered the Big Bang mythology. Remember, he invented the term Big Bang. It must have been kind of painful to him to see it mentioned so often. Now, I should mention to you that, as I point out in my first book, Losing the Nobel Prize, people didn't initially claim that the CMB was proof that there was a Big Bang. In fact, the words Big Bang are never mentioned in Bob Dickey's paper, which is a companion paper to the Penzias and Wilson paper, kind of maybe trying to share credit, maybe get the Nobel Prize for the theoretical understanding of it, even though they had famously been scooped for the experimental discovery by Penzias and Wilson 12, 15 miles away. But at that time, they didn't mention the Big Bang Theory as an alternative to what they believed was the dominant reason for the existence of the CMB, which is that a previous universe had collapsed and in a cyclical universe fashion had emerged not from a true singularity necessarily, a true Big Bang, but had launched into an expansive state, which led to the cooling of microwave photons. That was the interpretation in the companion paper. Now, Hoyle wasn't buying any of this stuff. He accused the Big Bang theorist of doing what grade-grubbing students do, plugging and playing to get the right answer. In a characteristic statement showing his bluntness, he wrote, "Had the observation given 27 Kelvin instead of 2.7 Kelvin for the temperature, then 27 Kelvin would have been entered into the catalog, or 0.27 Kelvin, or anything at all." But here's where Hoyle's genius shines, and even in great defeat, even in apparent defeat, rather than accept the conventional interpretation, he built an alternative explanation from first principles. If the steady state theory was correct, where could the 2.7 Kelvin microwave glow come from? Hoyle's answer was magnificent in its audacity. Dust, not just any dust, metallic whiskers, cylindrical grains less than a millimeter long, kind of like this fluid suspended here, or that iron filing that you can play around with a magnet and a compass. It's really microscopic versions of these meteorites that you get at briankeating.com if you have a .edu email address and live in the US. They're microscopic grains, or perhaps less than 1 millimeter in length. They would have been scattered throughout intergalactic space, according to Hoyle and Burbage and others. These tiny metallic needles would behave like a set of innumerable compass needles aligning with the galactic magnetic field and transforming ordinary starlight into microwaves through a complex process of absorption, scattering, and re-emission. Now, I really admire his creativity here. It exemplifies one of the most important principles in Hoyle's approach. When confronted with apparently contradictory evidence, don't abandon your theory first. Extend it next. Most scientists would have conceded defeat, and truly he might have been advised too, but he developed a more sophisticated model. Working with his collaborators, including the Burbages and past gas giant Narlikar, who recently passed away, Hoyle made a detailed calculation and found that his dust model could exactly predict a cosmic temperature of 2.7 Kelvin, right on the nose. The very evidence that supposedly destroyed the steady-state theory could be explained within its own framework if you were willing to think creatively about the role of interstellar matter. Now, what was more plausible? That stars could produce micrometeorites after their death, which Hoyle had shown a decade or so earlier, or that the universe emerged from nothing and produced its own fiery internal glow that would then cool off due to cosmic expansion over billions of years to reach 2.7 Kelvin. It's obviously more economical, parsimonious, Occam's razor successful to adopt Hoyle's technique, but it's not about whether he was right or wrong about the dust. He was wrong, by the way. And he was wrong primarily due to the fact that we can show that the CMB would be extremely highly polarized. And if not polarized at a level greater than maybe a part per million, it would have been polarized at the maybe tens of percent level if that were true. And that was ruled out very early on. But he didn't give up. So many revolutionary ideas face periods when the evidence seems to contradict them. The question is whether you have the courage to keep building, keep calculating, keep searching for alternative explanations, and then know when to quit. Now, here's an example of how Hoyle, acting as an enemy to the Big Bang, accidentally proved it right. Just before the CMB was discovered in 1964, something extraordinary happened that would test Hoyle's intellectual honesty to its core. Working with Roger Taylor, Hoyle published The Mystery of the Cosmic Helium Abundance, a paper that would partially vindicate his greatest rival. By examining astrophysical sources across the universe, Hoyle and Taylor made an astonishing discovery. The amount of helium in the cosmos was far too abundant to have originated from solely within stars. It had to come from somewhere else. It could not be his favorite champion object, the stellar nucleosynthesis process. It couldn't account for the universe's helium inventory. And by the way, this is what I've often used to reject people that I believe are intentionally misleading you, like Eric Lerner and the LPP fusion folks, that know this is true, that know that the greatest enemy of the Big Bang, far more competent and celebrated a scientist, Fred Hoyle, knew that his model, the steady state model, which is a variant of what someone like Lerner would support, was not true. And he was willing to give it up, or at least give credit to the rival model. Lerner and his ilk never do. A lesser mind might have suppressed the result, ignored its implications, or found a way to explain it away. But Hoyle did something that required incredible intellectual courage. He published it. He published evidence that supported his rival theory, the Big Bang model, that he despised. The implications were unavoidable. If stars couldn't make that much helium, it had to be produced somewhere else. And the most plausible candidate was, unfortunately for Hoyle, the hot, dense early universe that the Big Bang cosmology predicted. This moment reveals perhaps the most important principle in all of science. You must be absolutely honest about what the data tells you, even when it contradicts your deepest convictions. Hoyle's willingness to follow the evidence, to follow the data wherever it led, even when it led towards his intellectual nemesis, demonstrates the kind of integrity that separates genuine scientists from mere advocates. But even in this moment of apparent defeat, Hoyle maintained his skeptical edge. According to him, the Big Bang's appeal wasn't scientific, it was psychological. And I quote him, "The reason why scientists like the Big Bang is because they are overshadowed by the book of Genesis." He saw the Big Bang cosmology as cryptotheology disguised as physics. The actionable insight here, never let your theoretical preferences override your commitment to intellectual truth, empirical truth. The scientist who can honestly report data that undermines their pet theory is a scientist whose other work you can trust completely. They have complete epistemic humility. Finally, we get to the rejection and recognition that he had deserved but only got a partial dose thereof. In 1983, William Fowler won the Nobel Prize, shared with Subramanian Chandrasekhar, for work on stellar nucleosynthesis, work that was fundamentally based on Hoyle's original insight, the Hoyle miracle, remember that? How stars could produce carbon. Hoyle's exclusion from the Nobel Prize remains one of the most shameful decisions in Nobel Prize history. It might have been accepted because Hoyle had actually spoken out on behalf of Jocelyn Bell Burnell, past guest on my podcast, for being overshadowed for winning the Nobel Prize in 1974. And by the time that Fowler and others won the Nobel Prize in 1983, that was 9 years after Hoyle's failed advocacy for Jocelyn Bell Burnell. So he had been extremely outspoken that they had basically committed an act of scientific injustice. And that cost him, because after that, he was basically a pariah, much more so than even I am, for writing a book about the ways that the Nobel Prize distorts and malinflicts science. But that's a story for another podcast. But to me, the story of injustice is so blatant that even his scientific opponents recognized it. John Maddox, the editor of Nature, and no friend to Hoyle's contrarianism, called the omission shameful. The man who had conceived stellar nucleosynthesis, predicted the Hoyle state, co-authored the B²FH paper, was ignored while his collaborator received science's highest honor. But the scientific community eventually acknowledged its error. In 1997, the Royal Swedish Academy of Sciences, the same group that awards the Nobel Prize, awarded Hoyle the Crafoord Prize, often considered the Nobel Prize equivalent for fields not covered by Nobel's original categories: physics, chemistry, physiology, or medicine, etc. So astronomy wasn't considered part of it, but then again, that's no excuse, because people like Penzias and Wilson won the 1978 Nobel Prize, and pulsars were obviously astronomical, and they won, or the radio telescope won in 1974. So this admission of guilt, it's basically a little bit, amounts to a bittersweet recognition for Hoyle, but the citation perfectly captured Hoyle's scientific character. The citation reads as follows. In Hoyle's most well-known work on the origin of the elements, his later work has particularly been directed towards cosmology and the nature of interstellar dust. This work is characterized by new and interesting ideas, and sometimes speculation. Note that word, speculation. Even in recognizing his genius, the scientific establishment couldn't resist a gentle poke and rebuke for his willingness to explore unconventional ideas, panspermia, pterodactyls, and so on. This reveals the tension between scientific creativity and institutional respectability. This defined Hoyle's career. The deeper lesson here transcends scientific politics. True intellectual courage often comes at the cost of conventional recognition. Hoyle's willingness to champion the disreputable ideas from steady-state cosmology to panspermia to anthropic reasoning may have cost him the Nobel Prize, but it also ensured his intellectual freedom. Fred Hoyle died in 2001, spared from witnessing the final observational defeat of his quasi-steady-state cosmology. But by then it didn't matter. His legacy wasn't any particular theory of his, it was a corpus of work. His demonstration that science advances through the collision of bold ideas with rigorous testing. The question that his career poses to every ambitious thinker: would you rather be conventionally respected or intellectually honest? Hoyle chose honesty, and history vindicated that choice. The Nobel Committee's oversight became a permanent stain on their reputation, while Hoyle's willingness to follow his curiosity wherever it led became a model for scientific courage. Even after the CMB's discovery seemed to doom-steady state cosmology, Hoyle refused to surrender. Working with my late colleague Jeffrey Burbidge and Jayant Narlikar, past guest on the podcast, he developed the QSSC, the quasi-steady state cosmology, a more sophisticated version that could account for the CMB while preserving the elegance of continuous creation. But it required enormous amounts of dust, not just those little metallic whiskers, but it proved ultimately falsified by the CMB's discovery in 2001, 2002. What's remarkable about this period isn't whether Hoyle was right or wrong, it was his refusal to accept defeat without exhausting every logical possibility. Many scientists, maybe me, would have gracefully conceded long before, but Hoyle kept building, kept calculating, kept pushing the boundaries of what seemed to be impossible. Now, his cosmic dust fixation would prove to be prophetic. Cosmologists like Paul Steinhardt and others have worked on the cosmic theory that is sort of a successor of the quasi-steady state, the bouncing model, and you can hear about that in my interviews with Paul and Anna Aegis. But his obsession with interstellar dust would then later rear its ugly head in my experiment Bicep 2, and again, that's a story for another day. But never underestimate the long-term value of rigorous thinking, especially when it leads to being apparently wrong and being outside the mainstream. Hoyle's failed theories, quote-unquote, advanced our understanding of science. They took us to places that other cosmologists feared to tread. And Hoyle grappled with the fundamental question of existence. How does the universe generate and support life? Life that's intelligent. The final parting word from him encapsulates his mature worldview. Quote, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. This wasn't mysticism. It was Hoyle's response to the apparent fine-tuning of the physical constants that make complex chemistry, life, and consciousness possible. His anthropic reasoning, controversial at the time, anticipated our modern discussion about the multiverse and the nature of physical world. From Fred Hoyle's extraordinary life and prolific output spanning his technical papers, popular science books, and science fiction, as well as his autobiographical reflections, we can extract several principles that you can use in an actionable sense to have breakthrough understandings. Number 1, the contrarian advantage. Never accept conventional wisdom simply because it's conventional. Hoyle's greatness stemmed from questioning assumptions that everyone else took for granted. The steady state theory, stellar nucleosynthesis, anthropic reasoning all emerged from a willingness to think independently. Number 2, intellectual cross-training. Pursue knowledge across multiple domains simultaneously. Hoyle's insights came from combining nuclear physics with astronomy, eventually archaeology, mathematics and philosophy, and rigorous scientific communication, along with imaginative speculation. Modern problems require these interdisciplinary ways of thinking. Number 3, communication as delivery. Use multiple formats to develop and stress test your ideas. Hoyle's radio lectures, popular books, and science fiction weren't side projects. They were laboratories for forging and refining his understanding. If you can't explain an idea clearly, you don't understand it completely. Number 4, institutional independence. Never let organizational structures constrain your intellectual development. Hoyle's departure from Cambridge, controversial at one time, freed him to pursue ideas that might have been impossible. Number 5, embrace productive failure. Be willing to be spectacularly wrong in pursuit of being occasionally right. That's all most of us ever get. Many of Hoyle's ideas proved to be incorrect, but his willingness to propose radical alternatives advanced science by forcing consideration of new possibilities. Fred Hoyle died on August 20th, 2001, having lived long enough to see many of his insights vindicated and many, many more definitively refuted. But that's okay. His obituary in Nature magazine called it shameful that he never received the Nobel Prize for his work in stellar nucleosynthesis. But perhaps that missed recognition is fitting. Hoyle was never motivated by conventional honors. What matters most about Fred Hoyle's legacy isn't any particular theory, award, or discovery, but his demonstration that science at its best is an act of intellectual rebellion and courage. He showed us that the path to understanding requires willingness to question everything and explore everywhere and accept the possibility that our deepest convictions might be wrong. In our age of increasing specialization and institutional conformity, Hoyle's example reminds us that the most important scientific breakthroughs often come from those willing to be outsiders, spurned, ignored, ridiculed, but maintaining the rigor of a true insider. His life demonstrates that true scientific progress requires not just technical competence, but intellectual fearlessness. The question that Hoyle's life poses for each of us: are you willing to follow your curiosity wherever it leads, even if it takes you far from conventional paths? The universe is vast, complex, beautiful, and full of shocking surprises. Understanding it requires minds equally vast and complex and surprising. As Hoyle wrote in the conclusion of his wonderful book, Home is Where the Wind Blows, the universe is a put-up job. Whether he was right about cosmic intelligence remains an open question. But his approach to that question, fearless, rigorous, and uncompromisingly honest, provides a model for all of us seeking to understand the deepest mysteries of existence. The stars that Hoyle lit with his theoretical insights continue burning in observatories and textbooks worldwide. But perhaps his greatest contribution was demonstrating that the human mind, frail, tiny, pathetic compared to the cosmos, can be properly applied, and if so, it can illuminate the darkest corners of cosmic mystery. So my advice, go forth and question. The universe is waiting. I'll have links down below to Fred Hoyle's books and his papers, some of the inspirations, and my book, Losing the Nobel Prize, which has a Good deal to say about Hoyle, the Nobel Prize, and many other things. Check out my conversations, the Into the Impossible podcast, including past episodes with the renegades, mavericks, and rebellious figures that made modern science. Stay tuned for episodes about my late great friend and first guest on the podcast, Freeman Dyson, as well as episodes on Faraday, Maxwell, and Charles Darwin. Thanks.